Hello students, this is Brock Skaggs. I'm going to make this video showing you the use of the hole wizard inside of SolidWorks part files. And so the hole wizard is nice. It allows you to create holes very quickly, and especially if you're creating standard holes. So for instance, a standard counter sunk hole that's going to mate up with a specific fastener, also counter bore holes. Also if you're going to create internal threads in your holes, and so you've got a hole that's going to be threaded, you're going to eventually pass a fastener like a bolt down into it, and you want to be able to specify in that hole what actual type of thread it's going to have. And so you might have a quarter 20, half 20, and so forth there, and have that information described within the model itself, as opposed to, on the other hand, leaving it very vanilla and just saying, well, I'm going to get a sketch on this face, draw a circle in my sketch, and extrude cut it. And so then you just have obviously the position and the diameter there, but there's not a lot of other information you can embed into that feature of the part. And so where's the hole wizard at? Well, it's under Features tab, and you go to Hole Wizard. And so it's got two different tabs you can see, Type and Position. Generally I work in the Position tab before I go to the Type tab. And so one of the relatively new things in SolidWorks is the ability to create a counter bore hole. So I'll go ahead and do that. I'm just going to come down here and specify something, and then go up to position here. And so really, if you want to, you can start right at position. Here I just switched over to the slot, so I can show both the slot as well as the hole. And so here I've got the slot. I selected the face that I want to place the slot cut on, and so now it's inside of a 2D sketch environment, and it's waiting for me to fully define this line segment here. And so you've got this construction line here. There is a sketch point which appears to be at the middle of it, and it's basically wanting you to specify the location of this line as well as its orientation. And so here we'll just quickly put a few dimensions in here in order to locate it. If you want, we can put it right in the middle, but that's not quite fully defined for the slot because we're going to have to specify the orientation of the line itself. And so we could use just a geometric relation, so there's horizontal for us or vertical here, or we could have some intermediate angle really. So we could put it something like this and then apply a angle relationship there in order to, say, get 45 degrees. Once I'm happy though with the Position tab, I go over to the Type tab, and so here you work down the different options. And so for hole type, right now we're on a counter bore slot. The standard's ANSI-inch. Got a few different standards here. The type you can see is a hex bolt, or you could go to a socket head cap screw, having a little bit different geometry here. And you can just filter through the different options, as you can see. We don't want a near side countersink here, which comes up. You can see the difference activating there, as well as size. So the slot length, make it a little longer if we'd like, or a little bit shorter. And the end condition here. Here up to next, basically going to go through the entirety of the plate that we have. And so after you're happy with all the options, just hit accept, and it creates the geometry for you. And so that's very nice that it created all that in one step. One way to create that would be to have two separate cut extrudes, but then you're starting to clutter the tree up because now you have two features instead of just the one. And so let's go back in there one more time to see the hole side of things. And so we'll work on a tapped hole here. Let's just say it's a quarter 20 tap hole. And so here I've basically got the type specified as quarter 20. I'm using the straight tap icon here. If you just hover over the different icons, it'll give you the tooltips to give you a little bit more information about what it is. And so now I'll go straight into Positions tab, which usually I do start here, but in these cases I'm not, just so I can make sure I've got a hole or a slot to begin with. And let's put in two different holes here. And so notice when you have the same type of hole and you're just creating it multiple times, you can do that in the side of the same hole wizard feature. And so here I'll go ahead and locate these sketch points in space. so I can fully define the position of the center of these circles. Now let's make that a little smaller so we don't end up interfering with the slot there. And so again, you can use the bottom side of the sketch window here. It's got fully defined there, your indicator showing if you are at an underdefined sketch or at a fully defined sketch. Of course, you would want to leave this as a fully defined sketch to make sure that you fully described the location of these holes. I can go back over the type size, make sure that all these appear correct, and then hit the green check mark to actually create the tapped holes. And so although there's no actual threads you can see here, you can see in the tree itself that it's saying that these are indeed quarter 20 tapped holes that will need to be made in order to make the actual physical prototype. Just like other features, you can pattern these, and so if I get in here to the linear pattern tool, I for instance can pattern the pair of quarter 20 holes to create this little array here. And so it looks like I've got 10 small holes total there. And so just because it's a hole wizard doesn't change anything with respect to the patterning abilities of it. It's just another feature inside of SolidWorks that we're patterning. And so hopefully that seems fairly easy to you, fairly intuitive when I'm just using the planar face here as my reference to where I'm placing the hole, but it can be a little bit different if you get to cylindrical faces. And so this example here of this somewhat flywheel looking component here, what I'm wanting to do is basically put a threaded hole through the top part of the hub down into the keyway region here so that I can place a set screw over the key. And so this will be a little bit different just because the reference here that I'm going to select is a cylindrical face instead of a nice flat planar face. And so the first part is the same. Go to Hole Wizard. Here I'll go straight into Position tab, and when I select the cylindrical face, notice it's dropping me into a 3D sketch here. And so it's basically waiting for me to left click once more in order to place the hole. And so I'll just left click like that, hit escape once because I'm not going to be placing any more points, and now it's waiting for me to fully define the location of this sketch point itself. And so here it's the same idea. You've got a sketch, you've got to get it fully defined, but since you're inside of a 3D sketch, you have a few more geometric relations. And so one that you can find very quickly is if I get that point selected as well as the front plane, notice I have an on-plane relation here. And so what this allows me to do is ensure that that sketch point always remains on the front plane. So in this case it was basically right over here, and it rotated strictly vertical, if you will, from the right view here, which is nice. And so now I need to specify some offset distance, for instance, from this face. And so one thing you might try to do is place it from the origin. And so here's where you have to be careful, because from the top view, you can't even see it from the top view, but from some views that looks fairly close. But if I go over to the front view, it's not what I really want here. It's very unlikely you would see that as the desired dimension on the drawing. Generally what you'd rather see is a dimension running from the point to the edge of the hub, just like that. And so this dimension is not a straight line distance between the origin to the point, but instead a distance measured along the x-axis. If you use the triad in the bottom left of our screen, showing the distance along that axis between the end of the hub, so this face right here, to the center of the hole, which is much more appropriate. Here I'll just put in a 0.5 offset. And notice at this point, with that one geometric relation and one dimension, that I have fully defined the location of that point. So now I can go straight into type as usual. It's like a little smaller than a ½ inch here, and go with a number 1032, and I'll again use up to next on both the end condition for the hole as well as the thread here. And so the thread being up to next and being the same end condition as the hole depth actually tells us that the thread will be all the way through the hole and not stop at some intermediate value, which is what I want in this case. And so accepting that gives you the nice hole geometry there for our part. And so I believe that should do it for the video. And so thank you for watching the video, and hopefully this helps you out in using the hole wizard in your SolidWorks parts.